You should be able to graph these. We talked a little bit about graphing your logs. We said how to change your base on Friday. Friday? Right, Friday. Okay, and here we go again. So I have to do my pens. Let's do this. How did I get this on the last time? All right, now I should be good. All right, so we talked about this the last time we met. And some of your calculators, you looked at some of your calculators, some of you have the ability to do the change of base. And you would find that in math, go all the way down towards the end, and it says log base. And then what it does is it allows you to put your base in here, and then your other value right next to it. It'll allow you to do that. If you don't, I told you draw a line like this. The one above stays above. You just changed it to base 10. Okay? Or you could graph all of these in base 10. We talked about just graphing them in base 10 because all the logs work like the exponents. They follow the same graph, the same characteristics, except it gets just a little bit tighter to the curve, to the axis here. So if you couldn't graph this, you could always graph this in base 10. And it will follow your same pattern as your base 2, your base 4, your base 8, whatever it is you're looking at. If it helps for this one, put this at the end.
Why is a lot of these disabled?
I think what happened is the last, like when they use these calculators for SATs and for all the exams we do, they collect all our calculators and we reset them. So they probably have a program that's canceling out those apps. Years ago, before Algebra 2, you couldn't use that in Math B. You were not allowed to use the change of base app. So they just allowed that in Algebra 2. So for some odd reason, they're still being canceled. I have to fix all these calculators to put them back on. And the 83s don't have that capability at all. The black calculators that you rent, they don't have the capability at all. You have to put it in this way. Okay, so you found your transformations. This negative out here was next to the y, not the x. So when the y goes from positive to negative, it's a reflection in the x-axis. So here's my original, the blue. I reflected it. There's my dotted. Excuse me. Then I did a vertical up 4. Okay, so it ends up with this red one. The domain is not affected. It's still from 0 to infinity. And the range is not affected. It's still all real numbers. The x-intercept, if you wanted to find it, I don't think you could find it right. Well, I guess if you flipped it into an exponential function, you could. But I told you don't worry about that yet because we kind of didn't spend too much time on going back and forth. I'm more concerned that you get the transformation, the domain and the range, and the asymptote. And the asymptote, what's the asymptote on this guy? X equals 0. Good. Boys in the back, you with me? Okay. All right. All right, same thing here. You're probably better off if you move the +3 out here. Okay, so again, log base 2. You're going to enter it this way. Put a line, log x, over log 2. Now, the problem with doing this is you're actually putting it in your calculator. You're depending on your calculator to tell you where your transformations are. I want you to understand all your logs go the same. I want you to understand your log when you graph this and where it's passing through and what your attributes are, and then do your transformation off of that. So it really wasn't that important to be able to use your change of base because all you're doing is sketching. So if you did this the way you were supposed to, you would graph your log graph. Any log graph looks the same, passes through the 1, 0 domain, 0 to infinity, range, all real numbers, asymptote x equals 0, and then do the transformation, shift it up 3. and then you could see none of these would change. Now, let's take a look at this x-intercept while we're here. Your x-intercept, where it crosses the x-axis, started at here, 1, 0. When you shift it, obviously it's going to change. Y is equal to 0 along your x-axis. So we're going to plug in a 0 in your equation. Now, in order for you to solve for this, you're going to have to flip it to an exponential equation. So get that to one side and change this to an exponential equation. Remember how I showed you how to do it? Log equals exponent. What's the base of your log? 2. That's the base of your exponential equation. What's the exponent? -3 equals x. So an easy way to do this is just flip it to an exponential equation. And the negative causes us to flip it over. So there's your 1/8. So you really don't need a calculator to do any of these. Right? Are you okay with that? We'll work on the next one, and we'll play with the next one a little bit too. Okay, again, you might want to put this behind here. Put it here. You've got a horizontal shift. A horizontal shift is going to change your domain. So instead of the 1, 0, if you moved 3, subtract 3, this is at the -2, 0. That one you can find because you're moving it over. Once you move it down, it's a little harder to find. So now you're going a horizontal shift left 3 and a vertical shift down 2. You're just moving this guy down 2. Okay, this one we can follow, but the x-intercept we won't be able to follow. So you've changed your domain. You were from 0 to infinity. You dropped it 3 down. You changed your x-axis, your asymptote, along your x equals 0. You moved that over 3. There's your new asymptote. These you should be able to do without using your calculator. Now, to find your intercept along your x-axis, and you can find your y, you can find both of these. You can plug in a 0, and then you would need a calculator to find your y if you're going to use log base 8. But to do this, plug your 0 in. Do this with me, guys. Okay, we're going to have to get this to one side and set up log equals exponent. Easiest way to flip from a log to an exponent. Whatever way you're comfortable with. Some teachers teach a little mnemonic that's the base to the something to whatever it's called. Whichever way you're comfortable with is fine with me. This is the way I do it. My log, my base is 8. My base of my exponent is 8. My exponent is 2, and I'm equal to x plus 3. And now you can solve. 64 is equal to x plus 3, subtract 3. And now I know where my x-intercept is. Okay, we didn't spend a lot of time going back and forth on them, so I didn't want you to have to worry about doing them for homework. Are there any questions on these? Nobody has any questions? Everybody's okay with this? So if I gave you a pop quiz right now, we would all be able to do this. So speak to me. What? How can't we do? Okay, and your last one. Again, if it helps, pull this over here, plus 4. If you don't have this down, I want you to do this without your calculator. Okay, let's start. Here's your basic log graph. I don't care what base it is, basic log graph. What am I doing first? Horizontal shift, right 1. So I'm taking this 1, 0, I'm moving it to 2, 0. Okay, I just changed my asymptote. I moved that over 1, 2. So now here I'm at the x equals 1. I changed my domain already. I changed my domain to 1 to infinity instead of 0 to infinity. Agree? Any horizontal shift for this one is changing your domain, changing your asymptote. Then I do what? Up. Vertical shift up 4. I take this guy, I move him up 4. This is the easiest point for you to judge by. So 2, 4 is up here. So now, there's my graph. There's my new graph. Did I change my domain or anything by doing a vertical? No. I changed my intercept. So now let's find your intercept. Okay, let's move this over. Log equals exponent. What's the base of your log? What's your exponent? Okay? So, the negative causes me to invert this. And add 1 to this. 1 over 8 to the 4th is 4,096 plus 1. You can do that in your calculator. You need your calculator for that. Or you can convert this to 4,096 over 4,096 and you get 4,097 over 4,096. So a little bit more than 1. Okay? Guys.
So what if there's no, like, you know how there's like x minus 1?
Mm-hmm.
What if there's just no exponent? What do you do?
Well, there has to be an x. You have to have an x. You have to have a variable in here somewhere, right?
Yeah.
And our exponents, our variable was in the exponent. But because we did the inverse of this, your variable is now part of your log statement. You have to have an x. Or you would just get a straight line. You would just get a log of a certain number. You would get one little answer. Okay? All right. Let's go back to your notes. Yeah. Taking a log and taking an ln are the same thing. The ln is what we need for your natural log. They work the same as a log because your natural log actually is when the base is between 2 and 3, 2.78 something or other. So they work the same. Now, these are some properties that you can figure out, but they're nice to recognize. So if I do the log of any base of 1, it's equal to 0. Now watch. Log equals exponent. The base is a. The exponent is 0. Isn't anything to the 0 power 1? So any base, log 2, log base 2, log base 10 of 1, okay, is the 0. Any base that I put to itself, a to the 1, that makes sense, right? A to the 1 is still a to the 1. A to the x equals a to the x. Yep. And this one says if your log base is the same and you change this number here, then these two have to be equal, which makes sense if you make an equal statement here, right? It's almost like saying x equals y because the log base is the same. Do you remember the log rules? When we had logs on both sides, you can take them away. Remember putting logs to both sides? How would I solve a statement like this? I got to get the exponent down. Remember this? We're gonna work on this tomorrow, but remember this? We had to take the log of both sides. And then you can bring down your exponent. Now, on the flip side of that, if you have logs on both sides that are the same, you can take them away. You can take your logs away on both sides. If I can put logs on both sides, I can take logs away from both sides. But they have to be one term, one term. They can't be multiple terms out there. So if I do this, um, these logs I can take away, and 4 is equal to x. I can put logs on both sides, I can take logs away from both sides. So that was one of our best features of doing a log. Okay, now, the same holds true for the ln. The ln has a natural base of e. So I usually, if I'm going to look for these properties, I put the little base e out there, because e to the 0 is 1. E to the 1 is e. E to the x is e to the x. And the logs work the same as the ln's. You can take them away from both sides. You can put them on both, you can take them away. Now, you can use an ln for any base, but you must use an ln for base e. So in a lot of the books, the college books, they will just really only use ln. Because if you can use ln for anything, it just kind of pays to use it all the time. Plus, it probably looks a little bit neater looking to write ln rather than log. So these are properties, if you get used to seeing them, they're kind of helpful when you work on this. Do you have to memorize them? No, you can kind of figure them out. You can figure them out as we go. So let's take a look at your homework and hit the beginning part of this. I'm going back to the homework that we just went over. All right. Let's convert these. We're going to go from an exponential to a log and a log to an exponential function. We're just switching them back and forth. My way, if you don't know any other way, line up your log, your equal sign, exponent. The base of the log is the base of the exponential equation. Circle your exponent, that's your exponent, equals 64. And isn't that a true statement? Another way that I used, this is the way I learned when I was probably, in high school. I start below, because if I cover this piece right here, if I cover that, doesn't that say 4 to the third? Right? So I start here, say 4 to the third equals 64. That's another nice quick way to convert back and forth. Cover the 64 because this raises 4 to the third equals 64. Or log equals exponent, whichever one you're comfortable with. Or if you learned a different mnemonic with the base and I forget what some teachers use a different one. So 7 raised to the negative 2. My negative causes me to take the inverse, the reciprocal, and that's the same as this. We're just showing that they work back and forth. They're not asking you to solve anything, just to convert it to an exponential equation or convert the exponential equations to a log. So that you can see they flip back and forth.
What about 15?
Okay, we'll get to that too. We're going to make a log out of this. So log equals exponent, 32 to the 2/5 power. Now you can put that in your calculator, but another way to do this is, see how this goes up here? It's raised to the second power. But this is the 5th root squared. So the 5th root of 32 is 2, and 2 squared is 4. You can absolutely use your calculator, but I'd like you to know where this comes from. Can anybody turn number 13 into an exponential equation? Manassas? 2? Good. 2 to the 1/2 is radical 2. Now the 1/2 is the same as the square root. There's your radical 2. Okay? Okay, this guy, let's turn this guy around. Log base 5,
Raise to the 125th.
not raised to the 125th, raised to the 3rd, log equals exponent. So out here, what's the exponent? 3. There's your 125.
That's okay.
Oh, okay, I'm sorry. 5 raised to the 3rd is 125. See it? And doesn't that make sense? Okay. What's the base for this guy? This was base 5. What's the base for this guy? Oh, I'm sorry. Okay, equals my exponent. 81 to the 1/4 equals 3. They don't have to look great. They just have to be able to flip back and forth. Okay? Just so that you kind of get a good feel for flipping these guys back and forth. Substitute the given value. Oh, this one. How do I turn this into a log base? Log base what? 6. 1/36. Good. So we're comfortable with this? Going back and forth? Sometimes it's easy to solve things in a log. Sometimes it's easier to solve things in an exponential equation, such as those x-intercepts. We had to get rid of the logs. This one just says plug this in, plug it in here. Now, there's a couple of different ways to solve this. You can put this in your calculator with change of base. Go like this. Do log 16 divided by log 2. Just put it in your calculator. You changed it to base 10. And you can get an answer. Or, just give it turn it into an exponential equation. Give it a variable, 2 to the y equals 16. So what power do I have to raise 2 to get 16? 4. Okay? And do you remember how to do these when we did these before? You change this to the same base, remember? Once your bases are the same, then you set your exponents equal to each other. Remember that? Probably a little while ago. The easiest way to, well, this is kind of obvious because it's really not a lot of choices you can get to make it y, but I do this. Bring this down to the same base. Once the bases are the same, then the exponents are equal. Yep. Okay. All right. And that was these guys. And then you can substitute in this value of x and solve it. And there's your properties. Okay? All right. Then I'm going to hold off on this. I'm going to hold off on this.